how far we could push the limits geometrically with unidirectional tape.
A unidirectional part, that level of draw is incredibly hard to do, and here you guys are.
Actually, we load these into the tool, into the injection mold.
The United States has got the largest aerospace industry in the world. When it comes to thermoplastic composites, we have seen probably most of the research happen in Europe, but this is changing really fast. And one of these companies in the United States is Tri-Mack. They specialize in thermoplastic composites. Go check it out. What's going on?
You've come to the right place. We're primarily a aerospace parts manufacturer.
Okay.
And so in terms of composites, we start mostly with unidirectional tape.
So we've got probably the hardest part is this one, and then we've got a weave here, and I can see the materials we're looking at here is we've got a PA6, so automotive type of temperatures.
Basically nylons and up on the plastics pyramid. So PEEK, PEI, PPS,
Really nice.
PEC, PAEK. We've got our deep draw enclosure here, which is a PEEK S-class part. We ran this tool with a number of different material combinations. So this is PEEK S-class. This is a nylon, a PA6 woven laminate. And so our whole concept with this was to challenge ourselves on sharp, deep draw, fully enclosed geometry to see kind of how far we could push the limits geometrically with the unidirectional tape.
And we were talking off camera about this part. That a unidirectional part, that level of draw is incredibly hard to do, and here you guys are.
Yeah, it took a lot of effort from our engineering team. Not everyone is here today, so shout out to Ben Lamb, who's one of our bright engineers who really pushed that project along.
Quick one on why we're focused mostly on unidirectional material forming compared to the woven. When it comes to UD material will mostly slide right next to each other when it comes to forming it, which makes it quite hard. But when you compare it to woven material, the material can actually rotate relative to each other, which makes it a lot easier to form around the tool. So the geometry that you just saw, which has been deep drawn, is actually really hard to achieve in a manufacturing setting. You have also some over-moulding on that particular part.
Yeah, so this one was what we call the one-step hybrid molded part. We use our automated tape laying machine to take pieces of tape off of the spools, cut them, lay them down onto a vacuum table, build our layup, and then bring that over to our 500-ton press. And melt the composite, cool it under high pressure to form a solid voidless flat laminate. We take the flat laminate, put it in an infrared oven, melt the laminate, and then form the geometry of this part in the injection mold while simultaneously molding those four features on there, and also insert molding these inserts into the mold.
So did you just press that in hot then to be able to?
So we load these into the tool, into the injection mold.
That's cool,
So this gets formed and these get molded.
All in one go.
Yeah, all at
awesome.
once.
It is worth highlighting the fiber forge machine that Tri-Mack has. What is unique about this machine is not many companies in the world have got that kind of capability. Tri-Mack has got the ability of using rolls of unidirectional tape, and that machine is pretty much an AFP laying up flat, and these thermoplastic panels get laid up flat, tacked in place, and then consolidated in a press afterwards. But this allows you to create a laminate of your exact settings, which is in itself quite unique. The NIR is also doing some capability acquisition in that field so that they can do some preform creation. If you haven't seen that video, go check it out. And I can see some more
this is another hybrid part. So this is one where we call the two-step hybrid molding process, where we make the flat laminate, we water jet cut out the geometry of the parts, and then on this part, right? You remember we melt the part and then form the geometry in the injection mold.
Yeah.
These stay solid. We don't melt them in injection mold. We just load them in similar to the way we would just load in metallic inserts like that. And so we load those into the injection mold it, and then you rely on the thermal mass of this,
right, because
this molding plastic.
It can transfer a little bit, isn't it?
Exactly. So you just kind of melt the surface of those inserts, and that's enough to give you a strong bond.
When you put it in the tool, your tool is slightly preheated to something, and then there's some thermal transfer, and then you have kind of like that connection happen there. What are your thoughts on the demand from industry, whether it's automotive, aerospace, consumer goods? What's the demand from the American market right now?
We're seeing a lot of demand right now, enough that more than we can handle. You know, we can't take everything that gets brought to us, but there's a lot of demand across primarily aerospace for us for thermoplastic composite parts, but also extending beyond aerospace and into other industries. But currently we've had to turn away a good number of opportunities to keep ourselves focused on serving key customers and key relationships. But
really nice.
There's a lot that you can do with it.
Yeah, very nice. Well, thank you very much.
Thank you.
Tri-Mack also does some incredible work with the company Victrex. That's for another video. If you have enjoyed today's content, please subscribe. It really helps the channel. In the meantime, I will see you soon. Peace.